Now, as you know that what is the first law of thermodynamics, so you know that there is a major limitation to the first law of thermodynamics. And what is the major limitation? Though you know that it actually explained that energy can neither be created nor be destroyed, and it can be converted from one form to another. Or you can say that the energy of the universe is going to be constant, right? So actually what happened, like when we talk about limitation of first law of thermodynamics, so the major drawback is that though it actually explains the heat transfer, that means it explains that like let us take an example, that heat flowing from hot body to cold body, right? So that first law actually explains that amount of heat lost by the hot body is equal to the amount of heat received by the cold body, right? But actually it failed to explain about the spontaneity, or you can say feasibility of reaction. It fails to explain the spontaneity, or you can say feasibility of reaction. So this is a major limitation, right? So first of all, we learn that what does spontaneous, or you can say spontaneity, or what does feasibility mean in the reaction. See, we see different kind of processes occurring around us, different kinds of reactions you can say occurring around us. So we have two types of reactions, or you can say we have two types of processes. One is the spontaneous, other is regarded as non-spontaneous. Now what is spontaneous? Spontaneous processes are those which occur itself under given set of conditions. That means they actually have an urge to occur. So that means we don't need to supply them with some external source. They actually they have a natural tendency to occur in that direction. So that means spontaneous processes that which occur itself under given set of condition. That is called as spontaneous. That means which has urge to happen or urge to take place. Or we can say that spontaneous process take place if only the initial initiation is required. Once it is being initiated, then the process keep on happening, and we don't need to provide an initiation in a continuous manner. That means we need to provide initiation only once, and once it is if it is initiated, it has a tendency to occur in the given direction. So those processes are called as spontaneous. Got it? That spontaneous are the one which have urge to occur in a given direction. That means you don't need to do anything. But there are certain spontaneous process where an initiation is required, only initiation. Once you initiate it, it is going to occur itself in a given direction. In contrast, the other process what we have is the non-spontaneous. Obviously, it will be opposite to the spontaneous. That means they do not occur itself under given set of condition. That means even you initiate it, or you can say if we see that whether they have a natural tendency or not. So we see that non-spontaneous are the one which do not occur itself under given set of condition, whether you provide the initiation or anything, but they have tendency not to occur itself under the given set of condition. So let us take few examples. Like we'll concentrate on the spontaneity here, the spontaneous process, because this is what is the limitation of the first law, that it does not explain the spontaneity, that whether the process is going to take place or whether the process is not going to take place. Like if I say that heat flows from hot body to cold body, right? So it actually explains that the heat flow from the hot body is equal to the heat gained by the cold body. But it actually doesn't determine that whether the heat can flow from hot to cold body or whether the heat can flow from cold to hot body. So that means what is the natural tendency? Like if whether it will flow or not, it is not determined by the first law. So if we take an example of spontaneous process where no initiation is required. These are few spontaneous process where no initiation is required. Actually, they take place by itself under given set of condition. Like when you add salt into water. Suppose you add salt into water, they will constantly move. You don't have to do anything. They will constantly move and it will get converted into salted water. But if you stir it, it will happen more fast. But if you are not doing any kind of stirring, then also it will take few minutes or a few span of time, and it will definitely get dissolved in the water. So there, if you provide an initiation, then also it's okay. If you are not providing initiation, then also the process occur itself. Second is the evaporation of water. Suppose you take a water in a glass and you just keep it in a room. After a few days, you will see that the water just get evaporated because the you can say the content of the water in the glass actually falls down, and with few days you will see that there is no water left inside the glass. So again, it has a tendency to occur itself. The next, flow of water down a hill. You know that whenever water is flowing, it flows down a hill. That means it has a tendency to flow itself, or means you can say the process occur itself under the given set of conditions. Likewise, if you add hydrogen to iodine, you see that the hydrogen iodide formation doesn't require any initiation. They both constantly react and they just give rise to hydrogen iodide. But there are certain spontaneous processes where an initiation is required. And once it is being initiated, the reaction occur, it has an urge to happen in the given direction. Like lighting a candle. Once you just light it, it will keep glowing, keep glowing, and the wax will keep on melting. So that means lighting of candle is a spontaneous process, but here you need to provide an initiation. Second, heating of calcium carbonate. Suppose you have calcium carbonate, you once heat it. It will constantly decompose into calcium oxide and carbon dioxide, and only the initiation is required. Again, if you have hydrogen gas and oxygen gas and you pass an electric spark, it has, you can say that it has a tendency that they will both react and they will form the water. So that means these are also spontaneous, but here we need to provide them certain initiation, and the initiation is not required throughout the process. It is just required in the beginning, and once it is being initiated, the process has an urge to happen itself. So these things are not explained by the first law of the thermodynamics. Now the question must be striking your mind that what special thing you can say is there in a spontaneous process that they happen if initiated, or they have a tendency to occur itself. And in contrast, non-spontaneous is lacking that special thing, that it doesn't allow this non-spontaneous process to occur itself. So definitely there is going to be certain factor which is responsible, which is present in a certain process and it is absent in a certain process. That is why some processes are spontaneous and some are non-spontaneous. So let us see that driving force. Let us see that driving force. What do you mean by driving force? That means the force which is present in that, the factor that is present in the spontaneous process which make the reaction happen itself, or you can say once if it is initiated then it keeps on happening. So let us study about that, what is that driving force that makes certain processes spontaneous and certain processes as non-spontaneous.